Okay, we may have another victim here. Looks like, yep, he's changing. We're going to catch this one in real time. Keep your eye on him. It looks just like the other fellows who changed. I'm looking at him under the Nomarski filter. I don't see any cilia action. This is just like before. And these little jerky movements are usually indicative of a morphological transformation. Current frequency is 1187 hertz. 1187 plus the 11th harmonic. Watch carefully, I'm just going to center the picture. This is a live morphological transformation of the Protozoa Paramecium Caudatum. The sudden jerky motions are most likely caused by, there you go, did you see that? There was a sudden little explosion internal. And there's a lot of activity happening inside the organism. We could zoom in, but we might miss the overall picture. Shall we take a chance? 513 seconds exposure at 1187 hertz plus. There's another big change. I'm hesitant to zoom in because we'll miss the big picture there. 1187 hertz, square wave plus the 11th harmonic. It's about 110 watts, a little high for me, but tonight's been having good success at 110 watts. Let's take a chance. We're going to zoom in with the 40x. Might be a little big for your screen there. Oh, he just fits beautifully. So let's keep an eye on him. I'm just changing the focal length there, the focal plane. Live morphological transformation of the Paramecium Caudatum. Will we see any further change? It seems so because he's shifting a little bit on the screen. Perhaps this will reveal the true nature of the change. Yes, we continue to see changes. Keep your eye on that organism. 600 seconds exposure to 1187 hertz plus the 11th harmonic. Look below, a small sphere is forming here outside the organism. It does not have cilia action, so the movement you are seeing is caused by the morphological transformation. This is happening in real time. Let me center the picture a little bit. It's floating a little out of picture. 40x objective. The date is July 23rd, 2008. This is at least the third major morphological transformation seen tonight and caught on video. There were several which were not caught on video. When you're busy filming one, sometimes others are changing. There's a lot of activity still inside the organism in this region, you can see with a microscope especially. Once they reach this stage of change where they're very round, what's that, 700 seconds approximately, it takes quite a while before you'll see any further morphological change, but it will happen actually, I think, if we stick on this frequency long enough. It just takes a long time. Yeah, down below he's continuing to expand. Another Paramecium Caudatum devitalized by a Rife-Bare plasma device. A Phanotron Helium, oh, there's a big change. A Phanotron Helium antenna. Pulsed radio frequencies. The OM1 Radio frequency transmitter, carrier frequency approximately 27 megahertz. Is amplitude modulated by an audio rate square wave input of 1187 hertz plus an 11th harmonic, which by the way calculates to 13,057 hertz according to my computer. The audio input is a digital audio input into the OM1 from a Macintosh computer utilizing a custom digital audio synthesis program that I wrote. You're seeing this live July 23rd, 2008, as seen through the 40x objective of an Olympus BX60 research microscope, courtesy of the Olympus DP70 high-resolution digital video camera. Changing the light levels inside the microscope, trying to see if we're any hint that there might be an additional change. There is a lot of activity going on in this one spot. And we see a little wiggle, which usually indicates something's about to happen. Now, I think if we look at the bottom right of the organism beginning to extrude and distend. Okay, here's another organism slowed down and then stopped. 1194 hertz. Let's see if in the next 7 minutes before I run out of video. Oh, see that jerky action? That could be indicative of a change about to happen. Keep your eye on that organism. This is classic. First they slow down, then they stop swimming. That's me just straightening out the slide. Nope, see that? Morphological transformation right there. We just saw it. He's changing live in real time for the camera. This is a morphological transformation of a Paramecium Caudatum. 126 seconds, so we saw a change starting at 100 seconds. The frequency is 1194 hertz. Keep your eye on that organism. Continued changes. Morphological transformation of the protozoa Paramecium Caudatum. I will try to center the slide. There he is. Okay. As their shape changes, they sort of get pushed around on the slide a little bit. I can see the cilia. I don't see any cilia action. I wish to make note, oh, he's trying to get out of the picture there, that the first sign that you are on the right frequency is within 100 seconds, they will begin to slow down their swimming. Then they will quickly stop swimming. Then the external cilia around the perimeter, he continues to change shape and drift across the screen. Then, after they slow down and stop, the next thing that happens is the external cilia stop moving. You may see the mouth cilia still moving after the external cilia have stopped. In other words, the cilia around the perimeter of the organism stop moving first, and then the mouth cilia. Watch for constant changes. This is in real time, 238 seconds exposure, 1194 hertz, plus the 11th harmonic, about 110 to 115 watts, SWR 1.18, a bare Rife or a Rife-Bare plasma device causing morphological transformation in the protozoa Paramecium Caudatum. We have seen effective frequencies ranging from 1178 Hertz up to 1200 Hertz. So there seems to be a range in which this happens. We'll keep our eye on this for as long as the film lasts. We have about 3 minutes of video left. Let's see what changes are going to happen. I anticipate we will get further changes. The date is July 24th, because now it's 12:13 in the morning. July 24th, 2008. Morphological transformation of the protozoa Paramecium Caudatum. Watch on the upper right, an explosion is occurring. I'm going to try to adjust the filter so you can see that better. I will adjust the exposure. This one is undergoing a little different transformation than we've seen. This evening this is the fourth, at least the fourth live transformation we have filmed. There have been many others which we have not been able to film, because as you're filming one, usually others are changing at the same time. Morphological transformation of the protozoa Paramecium Caudatum caused by a Rife-Bare plasma frequency device. It's frequency specific, a specific range of frequencies that will affect the organism. You can see other organisms are on the slide, very happily swimming around. This is not a thermal effect, or all the organisms would be destroyed. The parameciums respond as you sweep through a range of frequencies. You gradually discover those frequencies which are most effective. Now we're going to adjust the substage condenser in an attempt to enhance. Stand by, we're going to get a little bit overexposed there. We're going to try to enhance the effectiveness of the DIC filter by changing the substage condenser settings. Trying to get a little bit better texture view. That's pretty good. This was a Paramecium Caudatum. It is continuing to undergo a morphological transformation caused by a Rife-Bare plasma device. Look on the lower right, you can see a bubble emerging from the organism. It apparently is emerging to the top of the organism. As I change the focal plane, a small sphere seems to be being ejected off the top of the organism. 110 watts, 27 megahertz radio frequency carrier. The audio input is a square wave, 1194 hertz, plus the 11th harmonic, which is 13,134. The 11th harmonic provides additional emphasis to the odd harmonic structure of the fundamental square wave. In other words, enforces some of the upper odd harmonics. The square wave is made of only odd harmonics. Look to the lower left. We have other blisters emerging from the organism. And we're going to finish this video. We're running out of video, so we will finish this videotape as far as we can observing the morphological transformation of the protozoa Paramecium Caudatum caused by a frequency-specific Rife-Bare plasma device. The date is July 24th, 2008, 12:17 a.m. East Coast time, United States. Very successful night in the lab tonight, causing morphological transformations in Paramecium, specifically Paramecium Caudatum. It continues to change in a very slow fashion, but now we're at the end of our film. Back out a little bit. Yeah, I think we're seeing a morphological transformation. That's why it's moving. It's transforming in real time. Very good. Just straighten the center of the picture a little bit for you. Morphological transformation of the protozoa Paramecium Caudatum. July 23, 2008, caused by exposure to a Rife-Bare plasma device. The power is, we're up around 115 watts, which is a little high for my usual experiments. But we see we have an effect. Frequency is 1185 Hertz, plus the 11th harmonic. We've had about 300 seconds of exposure. We began to see the organism slow down and the first signs of change. We're definitely seeing morphological changes here. Paramecium Caudatum, July 23, 2008, 1185 Hertz, and the 11th harmonic, which is 13,035 Hertz. 13,035. And we see internally a very large change happening. Some internal membrane just ruptured. Major changes in this organism at 1185. Continued morphological transformation of the Paramecium Caudatum protozoa. This is live. You're seeing it in real time. It has undergone, excuse me, 460 seconds of exposure, and we continue to see changes in the organism. There may be other organisms changing at the same time, but we will stick with this one. Change the focal plane a little bit and see what happens. We might experiment a little bit with the DIC filter. see if we could do that quickly. And here comes the last part of the DIC. And now we'll see interesting changes. I have to make a few adjustments here very quickly on the microscope. Here we go. Now we should have maximum effect of the DIC. There you go. So we'll be able to get very interesting texture and color information. You can see internally we continue to have a morphological transformation. This was once a Paramecium Caudatum. This is happening live. You're seeing it at the actual speed that it is happening. We're going to adjust some of the lighting a little bit to highlight the various chemical constituents of the organism. Morphological transformation of a Paramecium Caudatum as seen through an Olympus VX60 research microscope with a Nomarski DIC differential interference contrast filter. We continue to see internal changes in the organism. Let's continue to adjust the DIC filter, which reveals some of the subtle textural changes. There's a beautiful color. Hopefully that shows up on your video as beautiful as it is here in the lab. By the way, you can tell this is not thermal because you can see other small organisms swimming by. See if any other organisms were affected during this period. Now I've used this is the same organism you were looking at for the last 10 minutes or so, changing its shape. But in this case, I've pulled out and I'm using only the 4x objective. So you see it in perspective, and look at all the tiny organisms swimming around on that slide. Many, many organisms still swimming, still alive. So this experiment was specific to this Paramecium Caudatum and falls very close to a frequency range where we have seen this effect occur before. Somewhere between 1178 Hertz and 1200 Hertz we usually can cause morphological transformation in Paramecium, and if you add the 11th harmonic, it's a little bit more powerful effect usually. This is really interesting because that little sphere, which I would conjecture came from within the organism, is showing continued activity. This is very interesting. But this is a 40x objective, so this would be a little tricky to need to move that over a little bit so we can center the picture. There we go. Very touchy business. 40x objective. Oh, we're seeing a major change in the organism. So continuing. Now this is interesting because it didn't just separate, it quasi-separated and then came back. This is really interesting. I think we're going to stick with this for a minute. Current frequency is 1186 plus the 11th harmonic, but I believe that change actually occurred at 1185, but when we hit 1186 we got even more changes. That's the organism moving somehow, not me. As it continues to change shape, it is that shape change causes it to move around a little bit on the slide. So continued morphological transformation of the protozoa Paramecium caudatum. Just look, oh, there we go. That's a nice color. And I think something dramatic is happening here, so we're going to stick with this guy. There may actually be another organism doing more dramatic things, but that shape is so unique and interesting, I can't believe it. And it continues to change. We continue to see changes. I'm adjusting the DIC filter. Let's put it back on auto exposure. Marvelous, growing in size. Not just a round sphere, so maybe the round sphere stage is an interim stage. You can see there are organisms swimming all around this, so this is frequency specific. Those organisms are apparently completely unharmed, amazingly, by this experiment. It's been about 50 minutes of total exposure time over a range of various frequencies. We continue to see morphological transformations. Look at the bottom of the picture. Another distension. There's a very good detailed picture. Continued shape change, continued microactivity somehow inside the organism. At some point, we will film one of these and put on the oil immersion 100x objective and see if we can't videotape that incredible amount of micro movement that goes on inside there. It might be revealing as to the nature or the cause of the morphological transformations. Obviously not caused by thermal heating, or all these small organisms would be doing the same thing. Not every single Paramecium caudatum will change at this frequency, but there is a range within which you begin to get more and more of them being affected. Now what's funny is that I have that on auto exposure, and it still looks a little overexposed, doesn't it? Let's drop it down a little bit. Oh, sorry. There we go. Okay, now we can look at that. So that was fascinating. We saw some more changes in that organism. Let's go look for some more. There's that organism you were looking at, and right next to him was this one. We turned totally around. I don't know if that's a piece of that one or that's a different organism. Love that texture. Look at all those creatures swimming around in there. Normally food for the Paramecium. They're dancing around happily, unaffected by this frequency. Frequency specific. Currently we're on 1186 Hertz plus the 11th harmonic. Okay, I did find another organism that changed. We didn't see it live, but you can tell from the view we saw with that other Paramecium that this obviously is a Paramecium caudatum that has changed, and there you can see its shape as revealed in the beautiful colors of the Nomarski filter. Perhaps we could call it the mortal oscillatory rate of the Paramecium caudatum. I doubt this organism is capable of any longer reproducing. or carrying out its normal functions, devitalized. Probably what Royal Rife meant. There was still activity in the organism, but it was incapable of completing its normal life cycle. I think we'll go back to, we're going to go backwards to these frequencies. Let's go to 1175, which was the one right before this. This is that same Paramecium who was changing shape into a little sphere, and you can see there's a small organism running rampant inside of him, either inside or underneath him. It's not clear. It's possible he actually ate that organism, and it remains in there undigested and essentially wreaking havoc. He sure looks like he's inside the Paramecium. Nope, he's on top. He's digging into his little tissues, because when I bring the focal plane up to the top of the organism, oh, he's going up and down through the Paramecium, because I can change the focal plane, and he goes in and out of focus, which means he's swimming into from below, into, and then from above, up and down, and swimming through the Paramecium quite freely. He may have one time been lunch, and is now, I would guess, looking for an escape route. Here we are zooming down into the Paramecium, and now we move the focal plane out and away. There he comes into focus, but he is definitely tearing up the tissues inside that Paramecium. And the Paramecium continues to undergo slight shape change. Let's look for more organisms. Just to show that this is frequency specific to Paramecium, I'm going to show you a free swimming Vorticella who's in this culture, who shouldn't have been in here, but he provides us with an interesting, absolutely healthy little swimmer. Pretty sure it's a Vorticella, but I don't see his tail, but he looks like a Vorticella. And maybe you can see he's moving pretty darn fast. I will put a little higher objective. Oop. And watch how fast he swims by the screen here. He's going to go right by a Paramecium who changed. Ha ha! So, there we have now he's going to hit an air bubble. Let's see what he does. And he goes north. Head north, young man. So here we're looking at a free swimming Vorticella. You can zoom out so you get a better view of that. You can see him zooming along the edge of the slide. Here he comes. And there he goes. And you can see other organisms swimming around. So this experiment has been quite specific to Paramecium caudatum. Another proof that this is frequency specific. Let me adjust the filter. I think you can see that. That's a Vorticella. He wasn't even supposed to be in this supply of organisms. And he looks totally fine. Although he's not retracting his tail. Normally they will retract their tail frequently. But if I zoom in, that's the 40x objective. A Vorticella is very small. We see that he still has movement. It actually doesn't show up as well on the video as it does in the microscope. He's actually vibrating back and forth very fast in the microscope. So that's what a thriving bacteria culture looks like. Now we could have some fun and keep this slide on and hunt for a couple of years and find the frequency for that bacteria. By golly, that almost looks like Bacillus megatherium to me. So again, we have bacteria of all kinds of swimmers, so we were only zapping Paramecium tonight.